Hi guys, today we'll discuss a Waterloo math contest problem that combines counting and number theory. It is a graded Gauss contest problem from year 2012. It is question number 24 of that year, and it says, stones are numbered 1 to 10. 3 groups of stones can be selected so that the sum of each group is 11. For example, one arrangement is 1 10, 2 3 6, and 4 7. Including the example, how many arrangements are possible? Let's first clarify the requirements of this question. The question asks how many arrangements or selections are possible. And remember that your selections must include exactly 3 groups of numbers, right? And also notice that each number from 1 to 10 can only appear once in your selection. So for example, number 1 appeared in the first group, 1, 10. So that means it cannot appear in the second and the third group, right? Also notice that you don't have to use all the numbers from 1 to 10 in your selection, right? So in the example provided, they used only 7 numbers. So in order to crack this case, right, the first question I'll be thinking about is, okay, what are the possible groups of numbers that I can create, right? So in other words, how can I group the numbers 1 to 10 together so that the sum is 11? And if you play around with the numbers, right, you'll see that you can actually form a sum of 11 by grouping 2 numbers together, right? You can also form a sum of 11 by grouping 3 numbers together, 4 numbers together, but never 5 numbers together. And the reason is, if you sum the 5 smallest numbers, right, 1, 2, 3, 4, 5, if you sum them together, you see that the sum actually exceeds 11, right? So therefore, the largest size of the group you can form is actually 4, right? Okay, so let's list all these groups, right? So the 2 number groups that you can form are 1 10, 2 9, 3 8, 4 7, and 5 6. That's pretty straightforward. What about the 3 number groups, right? How many can I form? So this question is slightly more complicated, and the way I went about this was that, okay, I want to know what's the largest number I can put in a 3 number group, right? Can it be 10? Well, obviously no, because if you put 10 as your first number, your second number could be 1, right? But that already gives you a sum of 11, right? So that leaves you no space for the third number. Can it be 9? Well, actually, that doesn't work as well, because if you put 9 as your first number, your second number can at least be, the smallest second number will be 1, right? But that also leaves you no space for the third number, because you cannot repeat 1 again to be the third number. So actually, the largest number you can put in a 3 number group is actually 8, right? And that leaves you, that means the second and the third number must sum up to 3, and there's only one way, right? 8 to 1 is your first case. If the largest number is 7, that means the next 2 numbers must sum up to 4, right? But you cannot use the 2 2 configuration to give you 4, so therefore the only possible group is 7 3 1 if you want the largest to be 7. If you want the largest number to be 6 in a 3 number group, then of course you have a bit of a choice, right? Because the next 2 numbers must form 5, and you can have 1 and 4 and 2 and 3. So you have 6 4 1 and 6 3 2. And of course you want the largest number to be 5. Okay, you're left with only one choice, right? Because you want the next 2 numbers to sum up to 6. You cannot use 1 5 because 5 has already been used. You cannot use 3 3 because that repeats. Therefore, you must use 4 and 2. And what about the 4 number groups, right? If you sum the 4 smallest numbers together, 1 2 3 4, you will see that this is actually 10, right? So you actually just need 1 more, right, to make the sum equal to 11. So you see that if you only want to add 1 more to this sum, you have to change the last number, the number 4, to number 5, and there's no other way, right? So these are all the possible groups that I can form so that the sum is 11, right? So the next question I want to think about is, how can I select 3 groups from all those possible groups without repeating any number? And of course, to keep myself organized, I'm going to split them into cases. And the way I split them into cases is based on the largest size in the selection, right? Remember, we could have a 2 number group, a 3 number group, or a 4 number group. So the first case I want to think about is, what if I include the 4 number group, right? So if 4 is the largest size, right, then how can I select 3 groups? And the second case I want to think about is, what if, okay, I do not include any 4 number groups. The largest size, including the selection, is actually a 3 number group. And of course, the last case will be, what if the largest size is simply a 2 number group? So let's start with the case of 4 number groups, right? Suppose, right, I select my only 4 number group, right? and which is 5, 3, 2, 1, and I say, okay, that has to be included in my selection. How can I select 3 groups, right? I can select the 4-number group, 5, 3, 2, 1, coupled with the 3-number group, and then a 2-number group. So that's my 4, 3, 2 selection. I could also do a 4-number group coupled with a 3-number group and the 3-number group. That's my 4, 3, 3 selection. Or I could do a 4-number group coupled with 2 2-number groups, right? So are they all possible? If you actually play around with the numbers, you see that, okay, the first 2 cases are clearly not possible, right? Because suppose you picked 5, 3, 2, 1, right? And that means you cannot use 5, 3, or 2, 1 again. You actually cannot form any 3-number group without 5, 3, 2, or 1. So therefore, the first 2 cases, right, or the first 2 subcases of the of having 4 as the largest size does not work. You also cannot do the 4, 2, 2 selection, right? Because after you select 5, 3, 2, 1, right, to be the 4-number group, right, you cannot use the rest of the numbers, right, to form 2 2-number groups. The only 2-number group you can form is actually 4 and 7, right? But you need a second 2-number group, and there's not enough numbers to form that. So therefore, you actually cannot select 3 groups and allow the 4-number group and include the 4-number group, right? So the 4-number group cannot be the largest size in your 3-group selection. What if I let the size 3 to be the size of the largest selection, right? So that means I can pick 3 3-number groups, or I can pick 2 3-numbers and a 2-number group, or I can pick 1 3-number group followed by 2 2-number groups. Right? So you'll see that the 3 3 3 selection is actually impossible because you cannot form 3 3-number groups without repeating numbers. Right? You'll see that the 3 3 2 selection also is impossible because, okay, you can actually form 2 3-number groups, right, without repeating. Right? You can choose 7 3 1 and 5 4 2, but you won't be able to use the rest of the numbers to form a 2-number group. Now finally, what about the 3 2 2 selection, right? 1 3-number group followed by 2 2-number groups. That is actually possible, right? And I listed all the possibilities here. So in total, there are 5 possibilities, right? And that leaves us to the final kind of big case, which is what if I only let 2-number groups appear in my selection? So there's only one kind of way to configure it, which is the 2 2 2 selection. And remember, we have in total 5 2-number groups, right, in the previous section. So it means I'm picking any 3 from those 5. So I know by the calculation of combination, I have 5 choose 3, which is 10 possibilities. However, for a grade A student, I do not expect them to know combinations, right? Because really, you get introduced to combinations and permutations in grade 12, right? So I'm going to list all the 10 possibilities here, right? If you keep your head clear, you should be able to list them without repeating any. So in total, you have 10 possibilities from the 2 2 2 selection. You have 5 possibilities from the 3 2 2 selection. In total, you have 15 possibilities.